In this video, we're going to review the Suvat equations and use them in the next video. In this video, I just want to go over what the equations are that we're going to be using to study acceleration and just explain what each letter in the equations mean. We discussed them in class last time, and this is just a quick review of what we covered on Friday of last week. So this is a set of equations that we use when there is in fact acceleration happening, that there is steady acceleration happening. And I want to be clear that in physics, when we say acceleration, that actually means acceleration or deceleration. Both terms are covered. So that means speeding up or slowing down. Both of those are considered acceleration. So we're not going to use that term deceleration in physics. We're going to just end up getting numbers that we use, and we'll have to use the problem to figure out what that actually means. Sometimes, not always, deceleration might be a negative number, but it's a little bit more complicated than that. But let's just be clear that whenever I say acceleration, we mean speeding up or slowing down. Now, there are three equations that we use, and I'm simply going to give you the equations in this video, and in the next video, we're going to use them. So first, we're going to write this, and that's the first equation. I'm going to explain what each letter means in a second. The next equation is an equation for velocity. And the third equation is the following equation right here. Now, I just want to be really clear. The way these equations work practically is I'll give you a story problem, and you'll plug in whatever numbers you're given in order to solve for the missing variables. So S means distance, and in one-dimensional motion, unfortunately, you're going to see that we use this interchangeably with displacement. I know there's a difference between the two of those, and we need to be careful about that, but S is going to mean distance or displacement. U is going to mean starting velocity. V is going to be your ending velocity. And again, that doesn't mean that you're stopped. It just means that's when we're at the final time in our problem. A is the acceleration. And T is going to be the time. And I also want to talk about units. So the units of distance or displacement are going to be meters. Starting velocity is going to be measured. There's two ways that we write this. We either write this as meters/seconds, and it's just a way of doing typesetting. It's just the way that they print this. You'll also see this as meters times seconds to the -1. Don't read into that too much. It's just two different ways of writing units, and that's true for ending velocity. What you'll see for acceleration is that the units are meters per second squared, which we will also write as meters seconds -2. And finally, time is measured in seconds. So what I mean by that is when I ask you how far did something go, you're not just going to say 30. You're going to say 30 meters. If I ask you what's the starting velocity, you're not going to say it's 5. You're going to say it's 5 meters per second. Or maybe it's 30, -30, because it's going backwards meters per second. That's the idea behind what those units are. They tell you what the thing is and what we're measuring it in. So that's a presentation of the equations. And what we're going to do in the next video is we've got some problems right here that we're going to take a look at and solve very carefully using these formulas.